Hi, my name's Wendy Olsen. I'm at the University of Manchester, and tonight I'm just presenting for you the British Sociological Association Study Group Subplenary, and it's going to all be about epistemology. So welcome, and we're going to have some fun. I'd like to share some PowerPoint slides because that's useful just to guide you and allow you to relax and enjoy this little talk. So here I'll share. I hope you're seeing my screen now. And I welcome questions on this. I'm at the University of Manchester. I want to thank my friends and colleagues at my Department of Social Statistics there. We're in the School of Social Sciences. And my objective today was to tell you about my critical assessment of the current dystopia of the growth of data science in sociological research, so in the same buildings and invading the same spaces, a crisis of path-dependent evolution. But I'm going to give a couple of examples. So it's going to be an informative lecture with a couple of real, explorations of data. Not really using data science methods, but exploring the logic of how we analyze data. So I hope that in the end, I'll be going beyond trends, beyond description into a much more critical assessment of what is to be done and urging you to teach about that in your classrooms or to help government officials and policymakers to work in that sort of way, which is a little bit different from how I see the data science people working at the moment. So I'll try and explain what I mean. And I have got some personal experience of this, so I feel that I'm in a good position to be talking about it. So I'm just going to change my slide to the outline of the talk. So I want to begin with something that I'm sure you're familiar with, that is the issue of the market-based growth in higher education in the UK. And I'll just fit sociology into that perspective. Then I'm going to look at the epistemological dilemma that we have really a threat to confirmatory factor analysis and hypothesis testing. Lots of things that are ordinary in social science are actually at risk now. But giving two examples became very interesting. I tried to use examples where information and data were being treated by data science, and I really delved into them and found out how they are thinking and how they are operating. And I really discovered that they're not doing exactly what they say they're doing. So a good scholar working with those methods would actually do what we normally do in social science. And I'll explain that. And I'm writing a paper on the same topic. So to try and explain and promote that kind of epistemology, which is quite deep, it has depth. Because the alternative I would offer is pluralism, critical social science, different theories competing to explain things, and trying to help people to deal with our complex world. So slide 3, I've raised an issue about market-based growth in higher education. I want to explore that issue, but really before I do, I should define some of the terms that I've been using. So particularly information and data. So information would be the evidence or the records that are available to us to peruse. Perhaps they can be used to gain knowledge, but knowledge itself is the ability to do something. I think of knowledge as practical abilities. And so you can have various kinds of knowledge. You could have knowing about how to do things, or you could know of things. If we knew of historical events, then we would have knowledge of those things. Having information or data doesn't guarantee that we would have knowledge. Having knowledge about something doesn't necessarily mean that we could do anything with it. So what seems to me to really count with our knowledge is what do we do with it? Not just having it stacked on the wall, which is how I would classify information. So data, just looking at the last of these definitions, data is more or less organized set of records or impressions. Data is usually outside of the human body. So it's been recorded in some way. It could be audio or written, X-ray imaging. And I think it's really important to think about what data is, because who makes data? Humans make data. So it's a human product. And I'm going to argue along the lines that these things are social products. They're not the product of an individual. So as social products, we need to think about data in a way that's a social epistemology. Well, an epistemology is a set of values or tenets for what could constitute valued knowledge. So that's all right. I think that's a pretty much agreed definition. But what's a social epistemology? So I personally would suggest, I would argue that it's a rooted set of definitions or tenets for what constitutes valued knowledge. And you could have 10 different epistemologies at one time, but they are actually specific to the place where they originated and to the time, say the decade in which they originated. So we can understand or try to understand the epistemologies of past eras. It's very hard to predict what will happen in the future in epistemology. And this material on social epistemology is well known in the textbooks on philosophy of social science, um, and generally tends to not take an individualistic approach to knowledge. So we usually don't think of it purely as something that is owned and controlled by one person, but rather that valued knowledge is a social question to be agreed in larger groups of some kind. So I wanted to mention some of the texts that I use to teach about this, to remind myself about this. David Byrne's been an important influence for me. Alan Bryman, a wonderful book from 1988 on quantity and quality in social research. And that was arguing that we need to use mixed methods and mixed sources of data and mixed types of data. Some of you will be familiar with these books, Blakey's books and Boersboom's article on the theoretical statements of latent variables. Very important for us to keep teaching people about this particular approach to knowledge and information. But what I want to argue is that I'm worried about the growth of data science, and particularly whether it might move into the spaces currently held by sociology. The fact is, from HESA, that's the Higher Education Statistics Authority, there's been a lot of increase of females in all the sciences, natural sciences, social sciences. But on the other hand, in our new market-driven system, there's an increase in the amount of study of computing and a relative decrease in the amount of study of social sciences. I don't know if you can see the numbers here, but these are tens of thousands of students. And social science has gone into decline the last couple of years, while computing has been rising rapidly. Just to take a comparison, geography is quite a small heading on the scale of things. So social science is very large, but not growing. And it could grow, it should grow. And one way it could grow would be to adopt social data science as a subset of data science and bring that inside the social sciences. But what happens to epistemology when we do that? That's the sort of question I want us to think about. But at the moment, it's not being planned. It's driven by popularity of programs. It's driven by who can afford to pay for the programs that are popular. And so, like in many other countries now, there's rapid growth in business schools, medicine, law, um, and computing. And there's a threat against the social sciences and humanities because the student subject choices lead to a biased growth. And I think this is so widely known. And meanwhile, in the UK, the student body's become globalized to a very large extent. It's about, I don't have the exact figure for that with me, because it varies considerably from place to place. So I live in a world where many of my classes are 98% non-British origin people, but you might be in a world where there's 80% UK origin people. I don't know. It's very, very mixed. But even the staff has become partly globalized, and that means change in the sources that are used in classrooms. So I think there is this epistemological dilemma that we're tending now toward some people saying, if you're quantitative, then you need to go computational. You need to go to exploratory methods. Data science is sometimes defined as computational social science or computational methods. And then what we lose is we may not be teaching people confirmatory methods. The word confirmatory here is from the factor analysis literature, where we contrast the exploratory method of put all the data in and see what factors come out with the confirmatory method, which is well theorized. So we have theory and knowledge about the situation, the social scene, and then we begin to choose variables to put into factors. So I'm using that particular definition of the word confirmatory. But also hypothesis testing, fantastic books about Popper, fantastic books explaining how hypothesis testing can be very logical and very cautious. But I'm worried that if people aren't reading into their disciplines, if they don't have a disciplinary training in social science, politics, or economics, then they won't be doing hypothesis testing. And they may just take all the data and put it in the pot and see what comes out, which is exploratory methods. So I would argue against that. And I would say in sociology, what we see at the moment is better. We see that we have a plurality of epistemologies. We don't say there's one epistemology. Different groups use different ones, and among them are social constructivism and realism. Many of the quantitative social scientists might use a sort of empirical realism. Some people say that they use logical positivism. And this can be critiqued. You know, you don't have to agree that all those are coherent. And each one might have advantages for working on a particular type of theme or data. But we're sure, all of us are sure in those four schools of thought, that the theme should drive the choice of your approach. The theme should be a driving force. The choice of a topic comes first. And then with that choice, we might decide what kind of logic to use. So again, it's agreed that we could use the logics of deduction and induction. You can use both. You can actually use them in the same article or together. So induction is from the data to the general findings, but deduction might be used in the hypothesis testing chunk. So you can have a chunk that tested some hypothesis in a cautious way. Abduction means, reasoning by learning about something from the inside of it, being a part of it. Retroduction, that means asking why things happen. Why do they happen the way they do? And I don't think that there's much disagreement that these four logics can be used. But are we teaching them to others? Are they going to be, pursued in the future? And isn't it interesting that although we disagree about epistemology, and we know there are these huge differences of approach, we still can agree about whether something is inductive, and we still can agree that it might be valuable to be deductive, because the deductive arguments have explicit building blocks, and so they're easier to pick apart and start to take issue with them. So actually, I quite like deductive arguments, even though I don't believe in really having axioms or mathematical arguments, but it's useful to have the arguments build up into more and more complex statements and bring in evidence at different stages. And I really like retroduction. So if I did do exploratory research, I would then at some stage ask myself, why did I get those results? What was it about the world that made the data in my computational stage look that way? And I would, embark on further research. I wouldn't just stick to the exploration stage. I would move beyond it. So I have found retroduction a really helpful step, and it's covered in Blakey's book on methodology. So let's give one example now. Knowing the local language is extremely useful if you want to inquire about the underlying causes and the historical mechanisms that have brought about the current situation. So if you want to do retroduction, you're going to need some languages. But this new market system discourages learning languages. People are in a huge rush to finish their master's degree in 1 year in the UK, to do a PhD in 3 years in the UK. Now I think it's extended more widely to 3.5 years, but there's not time to spend on learning an additional language. And that's quite worrying to me, because the more globalized we are, the more we need extra languages, not the less. So I've been very surprised, but I'll give some details. Here's the language that's used in the ESRC funding guide. They haven't exactly stopped funding language training. For PhDs, the current situation is you can only get it if the language is difficult. Well, what's a difficult language? So they go into a detailed definition of a difficult language. And in the end, it has to do with it being unwritten. So you can get funding for 12 months to study a language if it's an unwritten language. Now, you could get 6 months or 3 months if it's a click language or a tonal language. So basically Chinese, Japanese, Arabic, South and Southeast Asian, and a few African languages would qualify for some few months of training. Now, I know just to learn French, it would take me years. I have tried. I'm quite concerned that multi-language research isn't being encouraged. And in fact, PhDs are tending now to be driven down into a very, very narrow set of 3 papers. I'm so shocked because when they first introduced the PhD by paper, they said, well, you can write as many papers as you wish. It could be three or four, five, two, depending on your discoveries. But now it's like a machine. You have to produce these papers. And machining, has something in common with artificial intelligence, robots, and hypercomputerization. So I noticed one data science institute was recently renamed. It's now become the Institute for Data Science and Artificial Intelligence. So that's bringing to the fore the artificial intelligence. Is this because AI itself is being promoted? Is that deliberate? I'm not sure it's deliberate. I think it's that people are reacting to an emergent property of a bad system. So the system of creation of knowledge has generated ChatGPT and quite a few other AI systems. And the universities now are rushing to catch up and teach people how to create AI and how to respond to AI. But if a system has an emergent property, the system has path dependency. So it's going to be hard to stop it from producing more AI. The path or the causes that created the AI in the first place are probably going to keep reproducing the production of AI. So we need to think innovatively to change the path and to create other forms of knowledge and challenge the role that AI might begin to play. There's very serious concern about it. So we know from future studies and the study of trajectories over time, we need to make structural changes in the system. I have no doubt that we should be very cautious about getting too involved in the AI debate. But hypercomputerization is on our desks. It's in our working lives. So, for example, the PhD programs are managed by an electronic system. We have to input the data in order to tell about the progress of a PhD students. We have distributed form filling. So lecturers are doing the typing function, and the administrative function is dumbed down. We're creating call centers in the university. But who is actually caring for students? Who is planning? The planning has become very top down, and we are rapidly losing the democratic structures of committees and even departments. People are staying at home. We're going to lose our space. So if space doesn't define the scope of your discipline and people are just farmed out into their households to do their research, then there won't be a community of practice, which, if you know, is a technical term. Community of practice is how education traditionally held up its own standards of professionalism. So we're at risk of losing that. It's really serious. Students are telling me they don't read books. They do not read books. They look things up on the internet. And many of mine avoid using paper. I have 80% who think they don't need a pen in class. So when I give them a task to do in a class, like a buzz activity or an exercise, they don't participate. They sit silently with a computer in front of them, and they will not draw diagrams. They don't have much experience with drawing or writing by hand. So it's quite worrying, really. I would say it's a dystopia. A utopia is an envisioned future of warmth and enrichment, and a dystopia is an envisioned future trajectory of severe problems. But they don't necessarily have to come about. I mean, sociology teachers have been fighting against social inequality and capitalistic reasoning for a long time, decades. And with new cohorts, we have to fight to keep that ontic depth, the ontology, looking at social class and nationalism different from nationhood, all these complex things. They may get lost. I think individualism is becoming more common in the classroom and in the curriculum, and social class is beginning to get dropped, and ethnicity is beginning to be seen as awkward, and history is beginning to seem optional, when it should be the reverse. We need to know more history because we need to know global history now. So I'm going to move on to the next stage of my presentation. I'm going to look at two examples of the treatment of information and data. I'll try to just, sort of run over some findings because I've been quite impressed at how far I could go in data science or in data mining. And the two areas I've chosen were association rules and entropy. And I just thought I would share with you some of what I've learned. So the first area is association rules. It's a data mining procedure. Look at the two diagrams, A and B. These are transaction sets. So it's a system of thinking about the association between the transactions of different consumers. And A and B could overlap. And so we could use A to predict B. and especially if we had lots of data on many consumers' transactions. Now, we have such data. We have that in the household expenditure surveys. So I was able to compare the Indian consumers' expenditures on pearls and meat and vegetables and all sorts of other products. But in that data set, we also have social class. We have employment, we have enterprise activities, we have farming that they do. We know a lot about the social groups of the people there, but the books on association rules are data science books, and they do not teach you to look at the occupational placement of the consumer. So they leave out that information. I think they just ignore it. And my next step will be to write papers or books where I look at the social patterning and how the social location of different groups of consumers really strongly patterns their consumption. That would have been obvious if you'd looked at consumer theory. So association rules is kind of recreating the obvious. In fact, they're also not applying theory. So I just want to zoom in a little bit there. If they're not applying theory, they're sort of looking at these products like vegetables and turkey and beef and bacon and saying the data are informative. But it's like, well, let's ignore what we already know about society. Let's kind of pretend that we don't know what was already known about consumers, mimicking the rich and trying to create a sort of brand identity for themselves as a style in a tribe. You know, sociology knows a lot about consumers, and sociology is ignored in business schools when they're looking at these association rules. So what I found is my actual observation was that the data mining people are not being taught to apply theory, not to apply social theory. They're trying to find out from the data and then just report that. And usually they're trying to discover methods. So actually we could do better with the position that the social position predicts the purchasing pattern, and the data are informative. But the data are fundamentally about people. So my second exploration is a bit more complicated, and again comes from an area that has a mathematical angle to it. The mathematics in the previous example was about combinatorial logic, and it's quite easy to look it up. So any mathematics area that you might want to look up, when you feel like exploring it, you just look it up in Wolfram Mathematica or Wolfram Alpha. That's your Google search. It's not preferable to look at the Wikipedia because the Wikipedia has mistakes in these areas. It's not very clear either. So for entropy, I started looking at that to see if I could use entropy to examine ethnic groups and ethnicity in Greater Manchester. And it was helpful, but it got a bit complex. So I'm going to give you a formula for entropy and then try and interpret all this. So the entropy formula is the sum of P log P. We take the negative of that because the logs are all going to be negative. P is the proportion. So it's the proportion of the cases that fall into one category or group. And this traditional definition of entropy is called the Shannon entropy, discovered around 1948. And it's very, very useful. You can do different formulas. You can change the formula slightly and still get the same results because you're basically introducing a bit of curvature into a surface. And to look at, say, a single variable ranging from 0 to 1, the most informative positions are when it's rare or when it's really popular. But if it's 50-50, like a coin, then the entropy is very high and it's not very informative to start flipping coins. So you flip your coin, say, 10 times, and it actually doesn't tell you very much. But if you have a condition that's rare or a random variable where the outcome is really rare or really common, then it has more information. So that's very strange, right? It's a strange usage of words. So I'm going to reiterate it. The key point about the information in any diverse variable or a variable representing diverse possible outcomes is that information is the converse of entropy. So if entropy is low, then it's very informative. If entropy is high, then the data is not very informative. And the example of coins is a good one where they're not very informative, really. It's not very interesting. But in ethnicity studies, when you group people into their groups, it gets really interesting about the small groups. Those are the informative groups. So in the informative groups, when we include them, we get lower entropy, but it's more informative. So if you can get used to that language, then you can measure it in units. We can call them nats. And you can really think about how valuable it is to draw samples of a certain size. So I found that entropy took me beyond power analysis. It took me into an interesting area. There were sort of new things that I could learn in that area, and it felt like it was social data science. So I'm just going to give a couple of examples now of what I learned, but I have to just define that a little bit more again. So think about a set. So the entropy could be defined as the degree of disorder in a set. So if you had a set as a cluster of items or the characteristics of all your people, then if the people were all homogeneous, then you have uh, a lot of disorder. And if they're very heterogeneous, then you have low disorder, and then you get a lot more information. So we could define information uncertainty as the entropy and informativeness as the converse of entropy. That might not really come across very well as you first come to the idea, but let me try and convince you. So just in brief, when entropy is high, information is low. When entropy is low, information is high. So this is what I mean by the converse, and we just have a simple numeric scale for entropy. So you have a scale for information. Well, it's really useful for Likert scales. So if you had 7 Likert scales, 7 to choose from on some sort of democracy measure or racism measure, you could choose which ones to use based on their entropy, and you're aiming for low entropy because you'll have a more informative set if you choose those 3 and ignore the other 4. So there's a basis for making decisions in entropy. The data set I have in mind for this left-hand side is the Asian barometers data set. It's full of Likert scales. In fact, there's so many Likert scales, you think, oh, I don't want to use all these. I want to choose some of them. And as experts, we make these choices, which are based on information. So we use the entropy measure for the information measure. So I could say more about it, I might. But the ethnicity example might be more welcome, like it might be more familiar. So we can have high informativeness of data where some ethnic groups are a tiny part of the random data. So I would say to you, from what I have the actual data here on these little spreadsheets, so maybe we could discuss that during the discussion time. I would suggest to you, do not stop your study of the ethnic groups in quantitative social science just because some group is small. Keep going even with a small group because you have evidence. It's precious evidence. That evidence of a small group is more informative than having lots of evidence about a homogeneous group. You see, so where heterogeneity is great, the information is precious. If necessary, with a small ethnic group in your whole population, use Bayesian methods. Bayesian probability estimates can be exact for the small n in some groups, or use probability itself. But if you aggregate ethnicities to solve the problem of the rare ethnic group, then entropy rises and informativeness declines. So you've hidden the key information when you aggregate. And we found in a previous seminar on feminist quantitative methods that deharmonizing was actually what feminists would tend to do in quantitative methods. And again, I found with the entropy measure that it was deharmonizing that would be valuable for sociology and not harmonizing. So another point is that my work on entropy was not exploratory. The entropy concept could be used to mystify and hide ethnicities. But what we should do is try and bring out the ethnic differences. So we must include and keep the small ethnic groups. Well, the evidence is in these spreadsheets. There may not be time to go into it, particularly because the Shannon entropies, which are shown here in color, they have to kind of be normalized, really. And I've given you here the non-normalized numbers. But in biology and engineering, they use this entropy concept a lot, and particularly in studies of ecology. So you have concepts like the richness of your diversity of species and the evenness of the spread of the people across those different groups. And these concepts have to be very carefully transferred if they come out of ecology into the social environment. Now we're actually reaching the point where we're using deductive methods. So what is a deductive method? It's where you stipulate some definitions as I've demonstrated. Then you develop some arguments, you draw in some evidence, And you build up the arguments one on top of another. So if something is weak, like the blue block is weak, then the argument doesn't hold up. But if they do hold up, then you have a warranted argument. And this is a really good way to construct arguments. This is the basis of some of the books that I've written. If there's a break in the logic, then the argument would fall. But if the data are informative, we can do a lot with them, you see? So far I presented information on the Shannon index of entropy. And I said it could have units, like perhaps gnats, but you could use mean squared error. And you can look at these data packages, or there's an R package, there's our formula. That's just a review slide that says what I've already said. The package in R is called entropy, so you could use that. You can measure the entropy of continuous variables. One method is called relative entropy, and another is called the Kullback-Leibniz entropy. But both of them are fundamentally about sort of the distribution, the difference between two distributions. So if you can imagine a histogram, then you can imagine this difference between two distributions. I work on the pay gap, so I can easily imagine the gender pay gap for women versus men is kind of the difference between those two distributions of pay, the two histograms. But I actually have examples from India. So in my Indian research, we do have an uncommon ethnic group, the Muslims. And the Muslim group is rarely pinpointed in public discourse now because it's very sensitive, but we should. So if we look at it in terms of Shannon entropy, then it gets very, very interesting. And I've got some numbers here to show you. Remember, if the Shannon is lower, if it's rare, or its absence is very rare, then you have more information. That's the green. But if the Shannon is higher, then, so say for rural and urban, there's quite a lot of people in both rural and urban areas, so there's no group is rare, and then you don't have so much informativeness. The same with sex in average adult groups. Sex is 50-50, so it's not very informative. What do I mean? These are the Shannon entropies for different social group memberships: scheduled caste, scheduled tribe, and Muslim in India. And you can see which one has the lower Shannon, so it has low entropy, so it has high informativeness, whereas being rural has high Shannon and low informativeness. And I've just switched the slide over to give a few more examples, because you can find something that you might not expect, like if they drink alcohol, if they say that they drink alcohol in a survey, and here the survey is the Indian National Family Health Survey, 2015. Well, only 6% of people said that they drank alcohol in that survey, whether you think that's accurate or not. And so the Shannon entropy is really low and the informativeness is really high. So if that variable was your dependent variable, or if it predicted a dependent variable that you were interested in, then it would be very helpful, I assure you. And you can make chains of these variables. You can have this as an anchor between, say, structural fundamentals and then drinking and health outcomes, and you can build a model. Maybe it's a structural equation model. So I am discovering now that by using entropy from data science, I can reach an understanding about a large data set, and then I can use that to do better social science. Wow. So to summarize the lesson about Shannon index, the lowest Shannon index variables are the ones with the most information about themselves in the sample. And here, for example, the percentage population Muslim in India was about 13% unweighted in the country. But the scheduled tribes and scheduled castes, which are also minority ethnic groups, they were larger groups, so they're slightly less informative in principle. We can look at entropy across groups of variables as well, so I'm now working on that. But when the entropy is lower, the informativeness of the variable is higher, and the correlation of that variable with other variables potentially could tell you a lot. So don't avoid mentioning a small group just because it's sensitive or because it's small, because we can do a lot with the information about group differences in that context. Now, I do need to move on, but I just wanted to mention Cronbach's alpha. For some years, I've been very concerned about the widespread use of Cronbach's alpha in factor analysis. If you've never heard of it, it's like a cross-correlation. And usually psychologists and psychometric experts say if the Cronbach's alpha is high, the variables are highly correlated and we get a good factor and a good fit. And it's a terrible logic because using Cronbach's alpha, it's a bit like data science. It's like we're just getting this pipeline of data and we're just trying to fit factors. So as long as the factor fits, that's all that matters. But that's a very poor epistemology, just to say that one number should fit another group of numbers. What we should be asking is how useful would that be for understanding society? And to understand society, we need to understand the diversity of people's personal norms or family norms or group norms. And this social diversity is missed when you just start trying to make factors because they fit. So if people disagree about gender, then you get a diversity in the Likert scale on gender. So I would question the value of just having a good fit in a factor. And I would say there's a lot more to think about. Borsboom's paper on this takes a position more similar to mine. So to finish on Shannon, the entropy concept can be used to guide some of decisions that you make before you start modeling. And the modeling decisions are still going to need social theories and social conceptualization and social ontology. Entropy measures can also be used to guide survey and questionnaire development or data scraping and the interpretation of social media data. So there's a lot that you could do with this concept. But there's no need for us to go into a data science interpretive mode just because we're using the concept of entropy. So we can extract new techniques out of their data science origin and bring them into social science, but we shouldn't let them colonize our sociology. I mean, just to start to conclude, I just wanted to stress 2 points that sort of go really looking at the positive arguments for data science and seeing where they're getting challenged. So one is that the UK government and the Scottish government favor looking at theories of social change. You have to have a theory of change in order to get funding from the development wing of the UK government. And having a theory of change is explained in this document. I've given the URL, but it's in the Magenta guide for how to evaluate projects as well. There really must be a theory of how a project, which costs money, would change the society to make it better. And that's fantastic. That is social science being embedded in the preferred government methods of evaluating and really generating social projects. Brilliant. What has that got to do with data science? Nothing. It has everything to do with sociology and social sciences. Another example is that if we look at data science literature, many of the textbooks mention the data generating process. Now, this is a strength in the data science literature. The data generating process, or DGP, is famously attached to the name of David Hendry, but lots of other authors have picked up on this now. So to give an example, in a hospital, data are being generated perhaps by administrators, but behind the administrator is the work of a nurse, and behind the nurse is the decisions made by somebody else. I'm the consultant. And this whole thing is a process that generates the data that results. So we have data on patients, but it may have biases and it's been shaped by the data generating process. This part of data science is unproblematic. It's extremely interesting. And, I certainly wouldn't throw out the baby with the bathwater when I'm being critical of data science epistemology. And I do take this very seriously. So that's nice that there are some good aspects of the data science literature. Many of the authors are really sensible, and they would say that you should test your hypotheses. They would say that you shouldn't just verify your own hypotheses. Do you remember that falsification was an alternative to verification? And it is better to try and falsify because you don't assume that your hypothesis is true from the beginning. You just try and test it and then see where you go next. And so many authors, as people, I can think of Harvey Goldstein, for example. I can think of quite a few people like Andrew Gellman, and they would agree with everything I'm saying, I think, today. I can't speak for them, but they're well-known statisticians, really, rather than data scientists. So I need to move now toward my conclusions. I've been trying to draw this great contrast between the epistemology of data science as exploratory, just gathering data and analyze the data, and the epistemology of social science. So to conclude, my preferred form of social science is actually critical social science. That's the tradition where you're problem-driven, Descriptions are aimed at giving evidence to stakeholders. The stakeholders are outside my room because I'm a scientist, and I'm trying to be balanced, giving the evidence back to stakeholders. But I get evidence from various sources. I try to get competing evidence on the same problem. And then the stakeholders can act on that evidence. And there's overlap between objectivity and subjectivity. They're not separate things. So my scientific decision about what I should say is partly an objective decision that I think any reasonable scientist would agree with me. And here's why. Here's my evidence. Here's my building blocks. Here's my wooden blocks in series. And if you can find a block that's weak, tell me what that is, and we'll look at it together. So you're trying to find out what is the case. Some people may not be that comfortable with the idea of the overlap of objectivity and subjectivity. They might be studying subjectivity, and that's all right. But subjectivity has a life in the material world. So because it has a life that's embedded or somehow resting upon or partly dependent on the material world, it may be, again, resting in part on some, if you like, objectively knowable aspects of society. Let's say aspects. We won't say foundations. So if you are studying subjectivity, you need to also study social class or, history and many things which can be known through means that are collective. And collective knowledge is sometimes called objective knowledge. I also promote methodological pluralism, and I think sociology is good at being plural in terms of theories. So I don't want to tire everybody out. I want to get a discussion going. I'm ready to oppose the market-driven higher education. I'm ready to argue that it's getting more and more capitalist funded. So the rich capital group, that class, is now able to buy places in PhD programs, and they can fund scholarships for people that will work with their company. I'm really concerned about that. I would question also that the education might be just driven by consumers. It has to be planned, and there should be a discussion about what should be done, what needs to be done. So I have some references there. Let's have a debate now. Thank you so much for your attention, and let me have your feedback. Thank you. So I'm just going to stop the recording there. Just by the way, the date is February 2024. And my email address is wendy.olsen@manchester.ac.uk. I hope that you would send feedback to me through email. I do have a place on YouTube. I'm in other social media like Facebook and LinkedIn. So I really welcome your inputs. Thank you very much. Bye-bye.